Hello everyone, welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Design Professional Exam. In this session today, you will understand few design concepts related to Aruba wired and wireless solutions. Before I move on, let me introduce the 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be covering few topics such as planning and designing, design specifications, evaluation of customer requirements, gathering and analysis of data, solution justification from Aruba Certified Design Professional Exam objectives. Let me briefly go through each one of them. Under planning and designing, topics related to selection of products for a given scenario, how a specific technology would meet customer requirements, and designing high-level architecture are included. Then design specifications include the designing and documenting the bill of materials, detailed design of logical and physical network solution, including network management and security. Evaluation of customer requirements covers the translation of customers' business needs into technical requirements. Gathering and analysis of data is to determine the information required to create a solution for a given outline of a customer's needs. Solution justification covers the explanation of how the recommended solution fulfill the customer requirements. Okay, let's look at the sample questions under planning and designing. The customer has an office environment with users who have laptops that can connect with wired or wireless. Users also bring one or two of their own devices. An architect creates a proposal with Aruba AP325s, 7210 mobility controllers, a mobility master, and Aruba 2930M switches at the access layer to support the laptops and APs. The architect plans to recommend 802.1x authentication without tunnel node on Aruba 2930M switch ports that connect to laptops. What is one advantage of this form of authentication? One of the important points here is that no use of tunnel node. That means wired traffic from Aruba 2930M switches are not tunneled to the mobility controller. Look at the diagram to visualize the scenario. Here the mobility controllers are clustered using mobility master. Wired APs are connected to the 2930M access switches so that we can assume wired traffic flows through the typical layer 2 path through access switches and then reach the core layer where the default gateways are defined to exit the local network. Let's go through the answers. Option A ensures that Aruba firewall policies apply to wired user traffic. Since wired traffic is not tunneled through mobility controller, it is not possible to apply Aruba firewall policies. So this is wrong. Option B prevents users from connection attempts with more than 3 devices. To enforce such device count per user, it is required to implement clear pass onboard kind of features to onboard wired devices using unique device certificates. But here in this question, there is no such implementation. So it is not correct. Option C enables user access control and ensures only authorized users connect. With 802.1x authentication implemented, it is possible to allow the authorized users to connect after successful authentication. So it seems the correct answer, but let's check the last. Option D provides a second layer of protection for wireless users at the internal perimeter. There's no relationship of the 802.1x wired authentication with wireless users. So this is not correct. So the correct answer is option C. Let's go to the second question under planning and designing. An architect needs to help a customer design a management and monitoring solution for an Aruba network in an airport. The solution consists of an Aruba Mobility Master, Aruba 7210 MCs, Aruba AP335s, and Aruba 5406R switches. The architect plans to recommend Aruba Airwave. The airport has a high client device turnover and many highly mobile devices. Which changes should the architect make to the recommended solution based on this characteristic? Question says it is a controller based architecture with Mobility Master and going to recommend Airwave as network management system. Important points here are high client device turnover and they are highly mobile. Since the solution has 7210 controllers, it can support up to 16,000 client devices per controller. So we can have an idea on the device density. Let me show you the Airwave server sizing guidelines. You can see the tested platforms along with the capacities here. The number of maximum managed devices per platform. So you can see the 1,500 devices up to 4,000 devices. So maximum number of devices that can be managed by a single server is 4,000. And the guidelines, whenever you have higher client mobility and if the client density is high, then there are guidelines here in this sizing document. Let me show you that also. So you can see client mobility. So this is largely a function of your environment, but now they say, so under client mobility, you can see it has been observed that maximum number of clients that can be monitored in an Airwave instance is reduced in networks with high client roaming percentage. So this means when the client mobility is high, then we have to increase the resources of the Airwave server because it consumes more resources. And the number of clients per AP. So the number of clients, if the number of clients per AP is increased, then you have to have more resources. Okay, it's clear now. Keeping things in mind, let's look at the answers. Option A, recommended additional hardware resources beyond those recommended for the typical tested Airwave platform. To cater the additional demand due to high client turnover and frequent roaming, it needs to provision the servers with extra resources than the typical tested Airwave platforms. So it looks correct according to what we have seen in the server sizing guide. Let's go to the option B. Recommend extra Airwave device licenses to support the changing number of client devices. Client devices do not consume Airwave licenses. Only the APs, controllers and switches consume them. So this is wrong. Option C. Recommend Aruba Central with a Clarity subscription as a more flexible cloud-based solution. Aruba Central doesn't go with controller-based solutions. It goes with Aruba Instant solution. So this is not correct. Option D. Recommend Aruba Central with guest access licensing to increase guest visibility. Since Aruba Central does not suit here, we can ignore this option. So therefore the correct answer is option A. Take a look at the next question under design specifications. An architect proposes the following Aruba solutions: 2 virtual mobility masters, 6 7030 mobility controllers, 300 access points. In addition to any necessary AP, PEF and RFP licenses, which license package should the architect propose? Okay, now need to understand the license management in Mobility Master based architecture. Here the Mobility Masters are used and they need to have licenses for managed devices. Managed devices include, we have 300 access points. So this is a managed device. So we have 300 managed devices and 6 7030 mobility controllers. So there are the 6 managed devices. Total 306 managed devices are here. So Mobility Master should support these 306 managed devices. And mobility controllers need these AP, PEF and RFP licenses. That is separate. That is already taken care of. So they are asking in addition to these licenses, what are the license package that need to be ordered. We'll go through the answers. 6 LIC MMVA50. So this is MM means Mobility Master. VA means Virtual Appliance. So this license package is 50 license, 50 Virtual Appliance license for Mobility Master. 6 numbers of this package. So 6 into 50 means 300. So it support up to 300 managed devices. But we need to manage 306 devices. So this is not correct. Option B, 1 LIC MCVA 250 and 1 LIC MCVA 50 and 1 LIC MMVA 500. So MC means mobility controller and VA means virtual appliance. But here in this question, there's no virtual mobility controller. So they are hardware mobility controllers, 7030, 6 numbers. So here there is no involvement of virtual mobility controllers. So there should not be MCVA licenses. So option B is wrong. Option C, 1 LIC MMVA 500. So this is this support up to 500 managed devices. This is for Mobility Master. This license support up to 500 devices. So this looks correct. Let's check the last one. 1 LIC MCVA 250 and 1 LIC MCVA 50. Okay, see here you can see mobility controller virtual appliance. So this is wrong because there is no virtual mobility controllers involved in this question, in this design. So the correct answer is option C. We'll move on to the next question under design specifications. An Aruba wireless solution for a very high density wireless solution consists of a mobility master and 2 mobility controllers. What is the best practice design for routing the wireless traffic? Since the question asks about routing, let me show you the default gateway possibilities in controller-based solution. Look at the picture. Now here you can see a mobility controller as layer 2. So then we are defining our VLANs in the mobility controller, and those VLANs are transported to the layer 3 core switch via this trunk. And all these VLAN interfaces, switch virtual interfaces, are defined in this core switch. So the gateway IPs are here. So mobility controller working as a layer 2 device, and all these layer 3 function is on the core switch. So this is the mobility controller as layer 2 scenario. And mobility controller as layer 3 means all these switch virtual interfaces and VLAN interface IPs are defined in the mobility controller. And there will be static or dynamic routing between mobility controller and the core switch. So in this scenario, all the ARP function has to be on the mobility controller. But here in this scenario, ARP table should be big enough to handle this default gateway service. So now ARP functionality in this mobility controller act as layer 2 device in this scenario. So layer 3 core switch is responsible for the ARP functionality. So in this scenario, mobility control is responsible for the ARP functionality. Since the question asks about a very high density wireless solution, normally it will be a large flat VLAN. So the gateway device should be capable of handling large ARP cache. Layer 3 core switch is having higher ARP cache compared to the mobility controller. So therefore layer 3 core switch would be better placed to define the default gateway whenever you have a high density Wi-Fi environment. Okay, let's check the answers. Option A, the mobility controllers provide the default gateway services for wireless devices and use static routes. This is not correct because mobility controller would not be a better place to provide default gateway service. as we discussed now. Option B, the mobility controllers act at layer 2 and the mobility master acts as the default gateway. Mobility master does not involve in traffic routing. Mobility master performs centralized coordination of mobility controllers. So this is wrong. Option B is wrong. Option C, the mobility controllers act at layer 2 and core routing switches act as the default gateway. This is what I have shown you in the previous image. Default gateway has to be in core switches and mobility controllers should be in layer 2. So this is correct. Option D, the mobility controllers provide the default gateway services for wireless devices and use OSPF. Mobility controller should not provide default gateway services for a VLAN with high client density because it doesn't have much higher ARP cache. So this is wrong. Correct answer is option C. Okay, next question under evaluation of customer requirements. A hotel chain requires a guest access solution. The hotel intends to offer free access to guests. Staff are limited and busy, and the customer prefers to make as few demands on their time as possible for the guest access. Which benefit of Aruba ClearPass guest should the architect explain? Let's underline keywords in this question. So they want to offer free access to guests, free Wi-Fi, and staff are limited. They have limited staff and they are busy. And they want to get rid of this overhead of creating, provisioning the guest accounts and all these things, stuff related to providing guest access, because they are limited and they are busy. So they don't want to spend their time on providing guest access. Let's look at how ClearPass will support, what are the licensed features that ClearPass product can support. ClearPass has three licensed features, actually three licenses. One is access, other one is on guard and on board. One is access license, other one is on guard, other one is on board. These are the basic three license types. Access license is compulsory. This will cover policy manager and guest. So the guest functionality is under access license. So this is applicable for concurrent sessions. On guard is for the posture checks. This is optional. So if you want to do posture checks before the client connects, so you need on guard license. This is applicable per device, one license per device. On board is to onboard the personal devices with certificate based. So it will provide a unique device certificate. Then it will onboard the device with a unique device certificate. So this is for this will work with eTLS. So this is per user. On board is applicable per user. On guard is per device. Access is based on the concurrent sessions. So this covers basically the licenses supported by ClearPass product. So we'll focus on the guest functionality. Now let's go through the answers first. Option A, it automatically deploys necessary certificates to guest devices. ClearPass guest will not deploy certificates to guest devices. Certificates are involved in ClearPass onboard for BYOD devices. So this is wrong. Option B, it prevents connections from devices with malware to reduce issues for staff. No malware protection from ClearPass guest. ClearPass on guard can do the posture checks before connecting clients to the network. But this is practically done on corporate client machines, not on guests. This is not correct. Option C, it provides a wide array of self-registration options. Self-registration is possible with ClearPass guest. Let me show you what ClearPass solution overview says about self-registration. So you can see here, guest self-registration takes the task away from employees and lets visitors create their own credentials Login credentials are delivered via printed badges, SMS, text, or email. So this proves that guest self-registration is possible with ClearPass Guest, and it will relieve employees from creating the guest accounts. Let's get back to the answers. So option C looks correct. So let me check the option D. It requires IT staff rather than receptionists to create guest accounts. Guest account creation can be done by any authorized users. But customer requirement is to get rid of that overhead as they have limited staff and they are busy. So this is not correct. Correct answer is option C. Let's look at the second question from evaluation of customer requirements. A customer currently has an instant AP deployment. Which customer requirement would indicate that the customer need to add a controller to the deployment? Let me explain what Aruba Instant is. Aruba Instant, you have APs connected to, let me draw some APs for you. Then they are connected to same subnet. So their management IPs are in same subnet. This is a switch. And once they are in the same subnet, so they form a cluster automatically. And one AP will become master. So once they are clustered, all the other APs will get the configuration from the first configured AP. So that is master. The first booted up AP will be master. And this solution does not require any license. So the recommended capacity is up to 128 APs per cluster. This is not a hard limit, but this is a recommendation. 120 APs per cluster. But you can go a number of clusters indefinitely. And per cluster, 2000 clients. So this is the sizing for this solution. This is Aruba Instant. This is most cost-effective solution from Aruba. If you want to go beyond that 128 capacity, then Aruba recommends to go for a controller-based solution with necessary sizing of the controllers. Let's go through the answers and see which requirement need a controller. Option A, the requirement to apply role-based firewall policies. Aruba Instant supports role-based firewall policies. No need to go for a controller. You can see in this image of Aruba Instant Firewall Rule configuration. You can see in this image of Aruba Instant Firewall Rule configuration. So all these firewall rules can be configured with Aruba Instant. So no need of a controller. Option B, the requirement for a captive portal for guests. The Instant supports basic captive portal for guests. No need to go for a controller. You can see that in this image of Aruba Instant captive portal configuration. So it has basic customization of the logo and terms and condition. So basic whatever the text you want to put there. So it has a basic customization. This is the inbuilt captive portal from Aruba Instant. Apart from that, you can integrate external captive portals as well. So no need of a controller. Option C, the requirement to provide client-to-site VPN access for remote users. To provide client-to-site VPN access, there should be a VPN concentrator to terminate the VPN tunnel. For this purpose, you need a controller to terminate VPN tunnels. So look at the image to visualize the setup. Hope this image is clear for you. There will be a tunnel from the Aruba Instant cluster towards the mobility controller at the head office or data center. So for that purpose, you need a controller. Option D, the requirement for a cloud-based management solution. Aruba Central cloud-based management solution is possible with Aruba Instant, but not with controller-based solution. You can see here in this image, Aruba Instant cluster can be integrated with Aruba Central with necessary subscriptions. So the management data is fed to the Aruba Central, so it can provide a better dashboard and monitoring and management capability. So no need of a controller. Directly you can integrate Aruba Instant cluster with Aruba Central. So the correct answer here is option C. Next question under gathering and analysis of data. An architect learns that a customer site is 14,307 square meters and supports 900 employees using Wi-Fi 5 GHz radio. What additional information should the architect collect to create the RF plan? So look at this image. So this is the typical floor plan of office. So now you recall the information that you need to create a RF plan. In other words, the heat map. So you need a floor plan with dimensions, details of the construction materials of the walls, because attenuation will differ based on the materials used. For example, concrete has higher attenuation than brick walls, and Wi-Fi client density in certain areas of the floor plan, and radio bands used in each area. Maybe certain areas you are not using 2.4, especially in high dense areas. So you need to identify those things, and with the presence of any radar signals, because it will affect 5 GHz channels. So those information and another tool to create RF plan. So those are the things you need to create RF plan. So we'll check the answers now. Option A, number of devices used by each user. Number of devices used by each user is required to have an idea of Wi-Fi client density. So this looks correct. Let's go through the others. Option B, the OS used on wireless devices. The OS used on wireless devices does not have any impact on RF plan. So this is not correct. Option C, whether BLE wayfinding is required. BLE wayfinding uses Bluetooth that works in 2.4 GHz and not affecting RF plan of Wi-Fi that is going to operate in 5 GHz. So this is not correct. Option D, software version on mobility controllers. Firmware version of the mobility controllers has no impact on RF plan of Wi-Fi. All firmware versions of mobility controllers support both 2.4 GHz and 5 GHz bands. So this is not correct. Correct answer is option A. We are reaching the final question under solution justification. A customer has very high availability requirements for wireless services. The architect plans to implement clustering on several Aruba mobility controllers. Which benefit of this feature should the architect explain? Question is about the benefits of clustering of Aruba mobility controllers. First, we look at an overview of controller clustering. Focus on the primary objectives of clustering. So you can see seamless campus roaming. How this happens is when the controllers are part of same layer 2 subnet, Wi-Fi clients can roam seamlessly because their IPs retained as they are, and their layer 2 and layer 3 information and sessions remains on same managed device. That means member controller in the cluster. So managed device is another word for the mobility control in the cluster. And the hitless client failover, that is another objective of clustering. Users that join the cluster always initially terminate on a mobility controller that is part of the cluster. We call it user anchor controller. However, users are evenly load balanced among cluster members. To move a client to another controller, the AP builds a new GRE tunnel to the designated mobility controller, and the user information is duplicated on another mobility controller. If this mobility controller fails, the user and AP continue on the backup mobility controller, and the new backup is selected. This gives hitless failover for clients. And client AP load balancing. When there is excessive workload among the managed devices, the client and AP load is evenly balanced among the cluster members. Both clients and APs are load balanced seamlessly. Okay, now let's go through the answers. Option A, clustering provides wireless client load balancing and seamless failover for client sessions. Yes, this is possible with clustering as we discussed just now. It looks correct. Let's check others. Option B, clustering provides high stability because one mobility controller is active for all sessions and one is standby for all sessions. It's not like that. Clients and APs are evenly distributed among cluster member controllers. So this is not correct. Option C, Clustering enables an AP with a failed mobility controller to operate on its own briefly to ensure seamless connectivity. AP with failed mobility controller will seamlessly connect to standby AP anchor controller. So AP cannot operate on its own. This is wrong. Option D, clustering enables an AP with a failed mobility controller to reconnect to a new AP after a short bootstrap. AP with failed mobility controller won't reconnect to a new AP. Instead, it will connect to standby AP anchor controller. This is wrong. So the correct answer is option A. Okay, that concludes our training for today. I hope you found this overview of Aruba Certified Design Professional exam topics helpful. We have discussed sample questions covering the areas such as planning and designing, design specifications, evaluation of customer requirements, gathering and analysis of data, and solution justification. Be sure to check out fi91lab.com for more online courses, practice exams, and training materials to continue your certification preparation. You can also visit www.fi91cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class, and I wish you the best of luck on your certification journey. Have a great day.